So today I've asked you to find the maximum and minimum points of a variety of quadratic functions, and this note is posted online. So the first section of this handout takes a look at a minimum, and we know that at the minimum the slope of the tangent line is going to be horizontal. So the slope of the tangent line becomes 0. Over here we can see in a maximum point that again the slope of the tangent line would be 0. Now this notation here is another notation to indicate that it's the first derivative. So we have a maximum or a minimum is going to have the first derivative being set equal to 0 because the slope of the tangent line is 0. So the note at the bottom asks you to look at how you can tell the difference between the maximum point and the minimum point. So visually it's very easy because obviously slopes of tangent lines are positive here, and then we have a horizontal tangent line, and then slopes of tangent lines are negative on this side, indicating that A would be a maximum. Over here we have slopes of tangent lines that are negative, and then we have a horizontal, and then slopes of tangent lines that are positive. So B would be a minimum. So we're going to take a look at the example that I've also posted for you today. And this example says the number of bacteria in a refrigerated food is given by n of t. And this function only exists when t is between -2 degrees Celsius and 14 degrees Celsius. And the question wants to know at what temperature the number of bacteria will be minimal. Now you could definitely have answered this question using grade 10 math by, say, finding the x-intercepts and then finding the vertex, or you could complete the square and write this in vertex form. However, we want to investigate over the next few days doing this using our calculus concepts. So we have 5 steps in order to do this. So the first step is going to be to determine n prime of t. And I would encourage you to do a couple of these using first principles just to make sure that you can get that answer. So I've used our shortcuts that we've discussed to figure out that n prime of t is going to be equal to 40t subtract 20. So that's step 1. Step 2 is to recognize that a maximum or minimum will occur when the first derivative is equal to 0. So we're going to set our first derivative equal to 0 and solve for t. Now I realized after I started writing this down, the question used capital T and I used lowercase t, but I hope you can still follow. So after setting 0 equals to 40t minus 20, I moved the 20 over by addition on both sides, divided both sides by 40, and I discovered that at 1/2 of a degree, the temperature is going to give us a horizontal tangent line. So step 3, which is very important, and a lot of students forget to do this step, is that you have to check to make sure that the horizontal tangent line occurs in the domain of the problem. So the domain was from -2 degrees Celsius to 14 degrees Celsius. So you do want to make sure that your answer makes sense in the context of the problem. Step 4 is also one that is super important because we need to actually show that it's a minimum and not a maximum. Now, if we look at the actual function, we know that this is a parabola that opens up because the leading coefficient is positive, but we're going to be looking at equations of polynomials where you don't necessarily know. So we need to make sure that we're checking and verifying that it's a minimum. So the calculus method to verify that something is a minimum is that we are going to make a chart. So in my domain, which goes from -2 degrees Celsius to 14 degrees Celsius, I'm going to look between -2 and 1/2 degrees Celsius. Then I'm going to look at 1/2 degree Celsius because that was our solution from above, and then from 1/2 degree Celsius to 14. So between -2 and 1/2, over here on the side, I picked 0, and between 1/2 and 14, I chose the number 1. You just have to pick any number in those domains so that the value that you're getting here is going to have the right sign. So if I substitute 0 in for t of our first derivative function, our first derivative is negative, and if I substitute 1 in for t of our first derivative is positive when n is 1. So that's how I discovered that for n prime of t, the function has negative values, then it's 0, then positive values. So that shows us in our picture here that the rate of change would be negative, and then over here the rate of change would be positive, so that we can make the conclusion there's a minimum in the middle. So at t equals 1/2, and at t has a minimum value. And this chart with this conclusion is very important to have as part of a calculus solution. And the fifth step, of course, is to just answer the question. So when the temperature is 0.5 degrees Celsius, the number of bacteria is minimal. Now, typically we would describe the temperature as 0.5. If you wanted to put your exact value answer as 1/2 degrees Celsius, that would be accepted. If it was a lot of decimal places, you would want to make sure that you're leaving your exact value answer there. So this is the full solution. You need to have the first derivative. You're setting the first derivative equal to 0. You need to do a check to make sure that it's in the domain. We need to make a chart so that we are verifying that is a minimum value, which is very important, and then we need to answer the question. Good luck trying the practice questions that I've posted online.